in 1021, we're going to move on from the statistical stuff and move into transforming functions. I think this stuff's a little bit easier. Essentially, the idea behind this is, let's say we had f of x, and that equaled 3x plus 2. And let's say, obviously, that's going to be a line, right? And it's y-intercept of 2, and then up 3 over 1. What if I wanted to make it go through here instead, and I wanted to subtract it 4? Well, obviously, I could go over here and I could subtract 4 and get 3x minus 2 instead. Or what we could do is we could actually rewrite it like this, where we have the f of x, that's the original equation, and we're just subtracting 4 from that. So this would be a completely acceptable way to write it, as would this. So that's the kind of the lesson here. So for instance, if we have one that's f of x equals 2x plus 3, and we have g of x equals 5x plus 1, well, if we add these together, it's going to be 2x plus 3 plus 5x plus 1 is going to turn into 7x plus 4. But we could also write it as f of x plus g of x. And again, this would be an acceptable way to write it, because when I say f of x, I'm talking about this, and when I say g of x, I'm talking about this. So that's kind of the lesson today. There's really not a lot more to it than that. It is that simple, I think. So anyway, the city pool wants to install a water slide. Your team has been hired to create plans for the slide. However, the pool regulations state that the ladder must have a slope of 3/2. And the slide to be used must be made using the equation h of x equals 10 to the 1/2 x, where h is the height of the slide and x is the horizontal slide distance. So when we go here, I think most of us know, and I don't know, maybe I'll make a little bit of room here. Trying to draw this, but if I were to graph this, obviously 3/2 x, I'm going to go up 3 over 2, and this is going to be my L of x. This is going to be the ladder, and h of x is 10 to the 1/2 x, so I'm at 10, then I go to 5, then I go to 2.5, so this would be like the slide. And I hope it's obvious to everybody that the ladder doesn't hit the slide, right? The ladder goes halfway into the slide, and that's kind of the point that we're making here. So we have these two equations. This is the ladder, and this is the slide, but you'll notice they don't really meet. So question B says the top of the ladder needs to meet the top of the slide. So sketch a simulation on a new graph. How can you change the function L of x? Well, if I wanted to do something like this, where h of x is here, and I want L of x to do this, where when I can climb up the ladder and then take the slide down, I guess what I better do is I better take this original L of x and I better add 10 to it, right? So that the ladder will meet the top of the slide, because that 10 is where the y-intercept is. So that's what I'm going to do. I'm going to express L of x as L of x plus 10, and that's going to push that up. So assuming the original slide drops swimmers off at just the height of the water, h of x and L of x, to create a new slide that will drop swimmers off 3 feet above the water. So I need to make a new slide. Again, h of x and L of x are dropping them off at the water, and I want to raise that up 3 feet. So I guess what I could do is I could say h of x plus 3, and I can say L of x plus 3. And again, that will just shift everything up. And again, that's the whole point of this lesson, is that we can rewrite it using that h of x and that L of x and that function notation. All right, 1076, using technology. It says using graphing calculator to investigate the effect of adding k to the functions. So what if I have, get this out of the way here a little bit. So I'm going to graph 2 to the x. So 2, again, this will get me an exponent. 2 to the x minus 3x. And let's go ahead and let's see what that equation looks like when I graph it. And you can see kind of an irregular, kind of curvy shape, kind of a cool shape. So what effect does changing the k have on this? So I could do one of two things. I can either go in here and I can rewrite the equation, and I can say 2 to the x again, minus 3x. And on this one, I'll change the k, right? This is going to be the k. I'll add 2 to it. So what we should see is that original line, that graph, but then it moves up 2. But another way I could have written it is I could have went down here, and I know that I have y1, right? That's what this is called, y1. So I can go vars, y vars, function, and I can steal that y1, and I can say I want to subtract 3 from it. So now I have the original y1. On this one I changed the k by adding 2. On this one I changed, I just wrote the y1, which gave me that 2x minus 3, and I subtracted 3 from that. So I should get one below it, and you can see that's the third one I wrote there. That's y3. So y1's in the middle, y2 added some to it, and y3 subtracted some to it. And you can see that all right there. What about if we were doing this in Desmos? So if we were doing this in Desmos, we could, again, have this equation. Y equals, geez, I forgot the equation already. Is it 3 to the x? 2 to the x minus 3x. Okay, so I'm going to say 2, and I'm going to go shift 6 to give that caret. So 2 to the x minus 3x. And I'm now just going to put a plus k in, and you can see what Desmos does with it. It asks if I want to add a slider, and I'm going to put yes, I do. So when I graph this thing, that's the original. But watch what happens. This allows me to sort of change that k and move it up or down, which is kind of neat. So again, just some of the differences between Desmos, which you might be using at home, versus a TI-84 or a TI-84 simulator. Just so you can see the difference in how it looks, but you can see you can do it either way. It doesn't matter which software you're using. You should be okay with that, or which technology you're using, I should say. Try another function. If you're choosing, does adding k to any function always have the same effect? So, I mean, I think we know roughly kind of what's going on here, but again, I guess it's going to be easier for me to change this equation than it is going to be the other one, so I'll change this. So what if I say 2x plus 3, and then, oh yeah, plus k, plus k. Okay, so then I have that slider, and you can see, yeah, it's moving it up and down. It might look like it's moving left and right if you're looking at the x-axis, but look at the y-axis, and you'll see that it's also moving up and down, just kind of one of the deals with the line there. I don't know. So the last one, 1077, pretty quick lesson today, really. Using the graph f of x right, so this is f of x right here, so we know that this is f of x. It says sketch f of x minus 1. Well, what I'm going to do is just go make the major points that are important. So you can see I'm just shooting to sort of hit some spots, and then I'll do the best I can of connecting them. But it's a pretty simple process. You can see it looks like it gets closer right there because of the curve. Now that's going to be f of x minus 1. And then if I want f of x plus 3, again, I'll just do the opposite. 1, 2, 3. I'll put these points up 3. And I will do my best again to sort of connect those dots. Looks kind of like a Kirby Charlie Brown sweater. So there we go. There's f of x in the middle. F of x minus 1, I shifted the whole thing down 1. F of x plus 3, I shifted the whole thing up 3. Again, hopefully you find this lesson a little bit easier than 10.1 through 10.1.4. I think those are a little bit trickier. Have a good one. Reach out if you have any questions.